talked last time about the collision coalescence process. So what is coalescence? Well, here's a couple images that hopefully help us to piece this together. As a cloud droplet gets larger through many collisions with other cloud water droplets, it gets itself enough mass to fall down. So the definition of coalescence that you need to know is merging of cloud droplets by collision. So we have two water droplets colliding, producing a bigger drop. You can actually do a really cool little experiment with this with a piece of wax paper. If you put some little water droplets on the wax paper and then blow on those water droplets, you can move those water droplets around to coalesce into a larger one. If we picture this on a larger scale, it's happening in a cloud. If a droplet is able to spend more time in a cloud, they get bigger. How would a droplet be able to spend more time in a cloud? Well, the size of the cloud matters, the structure of the cloud matters. If we have a taller cloud and we have strong updrafts within that cloud, the droplet has more time and more ability to get blown around in the cloud, moving around and building up itself by running into other cloud droplets. If droplets spend time in a less thick layer of a cloud, they're going to be tinier. So, by definition, a cumulus type cloud is going to produce larger droplets, larger precipitation droplets falling out of it, and more showery type of precipitation than a stratus type cloud. A stratus cloud, or a fog layer, which is typically a stratus cloud that's just sitting on the ground, that is going to have smaller droplets, smaller type of precipitation coming out from it because it's just not as thick. There's not as much updrafts to move the droplets around for them to grow larger. So here's a couple of pictures that we've got. If I take a look at here, we have this picture of this nice cumulus cloud, and we have a little cloud droplet making its little journey through that cloud and getting bigger. This shows a raindrop falling out at the end at 5 millimeters. So that's considerably larger than the previous raindrop we saw that was only 2 millimeters. You can see it's spent enough time in this cloud that it has grown from a tiny cloud droplet up to raindrop size, and then it falls out. The other picture kind of just shows small cloud droplets, and what happens as these larger cloud droplets start to fall, they have some wake behind them, and that wake actually sucks in other little cloud droplets, and by definition, they start getting bigger as well. Now let's see this in a little video, and this is a video a friend of mine filmed out here at the airport looking at a air conditioner that was basically running here, and I'm going to get this video to go here. The video just shows air being blown out of the air conditioner, and we can see what happens when we move into slow motion. So here is the slow motion part of the video, and if we take a look at what is going on just right above this air conditioner, the air conditioner is running, you can just barely see that we have some movement upward of these small precipitation particles. Obviously, these are raindrops falling, so they're pretty large, but you can see from this video, an updraft from the air conditioner here is enough to blow these little raindrops. They're probably like 2 millimeters to 4 millimeters in size. It's enough to blow these little raindrops up higher. We can actually see the updrafts in action. And let me fast forward a little bit through the video because we can see them a little bit better here toward the end. You can kind of see them bouncing around, especially if you look right at the area right above that air conditioner. So these are updrafts at work. The idea is we have the updrafts naturally occurring in the cloud, and picture this at work on a much larger scale, and you will see the coalescence process within the cloud. The next process I want to talk about is the condensation deposition. So in this process, water exists as vapor in the cloud. It can condense from vapor form to liquid on a water droplet. This is not running into it, okay? We have water in vapor form condensing onto an existing water droplet that can grow to the point where it's going to fall, where it gets heavy enough. This is the condensation. Deposition is very similar, except for we have ice in the cloud and we have water vapor in the cloud, and it attaches itself to a surface. Water vapor freezes directly onto a surface. That's called deposition. So the deposition process is where we have water vapor freezing itself onto a surface. And then in the condensation process, we have water that's condensing onto a liquid droplet. All right, the third type of method of generating precipitation. So first we have the collision coalescence. We have the condensation deposition process. And then the third one is the ice crystal or Bergeron process. This requires the temperature to be below 0 degrees and for us to have ice crystals and water droplets both present in the cloud. This process, this ice crystal process, also called Bergeron's process after one of the people who found it, it produces most of the rain that falls over northern and middle latitudes. What it really ends up being, the rain that falls if you live in North America, for most of North America, that rain falling at the surface is actually melted snow that was formed at snow at higher altitudes and then falls and produces this process. So this produces most of the rain that falls over middle latitudes, and that's a good thing to be aware of for future. So if we look at the supercooled water droplets, pure water that is suspended in the air will not freeze until we get to about -40 degrees Celsius. And that seems really crazy, but because the water is so pure, it doesn't have anything to organize on. It doesn't have any, it needs something to align. For a drop to freeze on its own is very, very rare. What it needs is either get cold enough or encounter some kind of surface. Could be an airplane, could be condensation nuclei, but if just pure liquid water suspended in the air, it doesn't freeze till about -40 degrees C. So for pure water droplets to freeze higher than -40, you have to have the molecules get aligned just right to form a crystal, but it's really hard because there's a lot of thermal activity that's happening within the droplet. There are some really cool experiments that you can do with supercooling water or even beer, and so I encourage you to look into those for a project that you will have in this class. This ice crystal process, again, most precipitation in the middle and high level latitudes, it starts off as snow. And we have water that starts evaporating from tiny supercooled droplets and then depositing. Basically, they're just like little water vapor. It freezes, deposition is freezing onto ice crystals, which form snow. This requires temperatures to be below 0 degrees. And here's our process kind of visually. So we've got supercooled water vapor molecules floating around as liquid, and they are water vapor. So we have a water molecule. We have basically little parts of these molecules then are going to flow over to the ice crystal, and they're going to deposit themselves on the ice crystal with the deposition process. As the ice crystal continues to grab the water vapor, it starts growing larger until that water droplet has gotten so tiny and that ice crystal has gotten bigger. Once that ice crystal gets heavy enough, it starts to fall. And on its way down, it also continues to collide with other supercooled water droplets, and they all start freezing onto the ice crystal, getting bigger. As that crystal gets bigger, though, it starts fracturing. It just starts breaking up into a bunch of little ice crystals, which form these beautiful six-pointed crystals that we know as snow. And so once it's formed this snow, then it continues to fall, and then in middle latitudes, during some times of the year, it's going to fall out as rain, producing most of our precipitation through this ice crystal process. And And then other parts of the year, other locations, it's going to continue to just maintain its shape as snow and fall in the form of snow precipitation.